NASA has finally unveiled the long-awaited images of the interstellar comet 3I Atlas, ending the wave of speculation that built up during the communications blackout caused by the US government shutdown. The release instantly grabbed global attention, and for good reason. The newly processed data confirms what astronomers suspected from the beginning. Despite coming from beyond our solar system, 3I Atlas behaves just like a natural comet. Now, with multiple spacecraft capturing fresh angles and new wavelengths of data, scientists have a far clearer picture of what this mysterious visitor is made of and how it evolved. In this video, we're breaking down exactly what these new images reveal and why this interstellar traveler is far more important than it might seem at first glance. Let's jump in. 3I Atlas was first detected in early July by the Atlas Survey Telescope. Within hours of analysis, the object stunned astronomers. Its trajectory wasn't just unusual, it was unquestionably hyperbolic. That meant it wasn't held by the sun's gravity and wasn't looping back around. Instead, it was slicing through the solar system on a one-time path, never to return. This immediately placed it in one of the rarest categories of objects ever observed. Only two other confirmed interstellar objects had been spotted before: the cigar-shaped Oumuamua and the icy comet 2I Borisov. The discovery of 3I Atlas instantly became one of the most significant astronomical events of the decade. But just as interest peaked, the comet moved behind the sun and entered its most active stage. This should have been a period of rapid updates and high-resolution data streams from NASA. Instead, the timing collided perfectly with the government shutdown, leaving the public with silence right when the comet grew brightest and most dynamic. That information vacuum was all it took. Rumors, theories, and speculation exploded across the internet. Once operations resumed, NASA released the full data set at once, along with explanations that addressed the viral social media theories head-on. The newly published imagery comes from a wide range of spacecraft. NASA's Mars Reconnaissance Orbiter delivered some of the closest and most detailed snapshots as the comet passed near Mars using its powerful high-rise camera. MAVEN added ultraviolet observations, allowing scientists to identify which gases were escaping as the comet heated up. Solar missions like STEREO captured wide-angle views of the comet's growing tails and dust streams. Even spacecraft on unrelated missions, including Lucy and Psyche, grabbed distant opportunistic views as the comet crossed their lines of sight. What makes this data set extraordinary is not any single image, but the coverage. Instead of isolated images taken from one location, scientists now have a continuous multi-mission record capturing the comet from different angles, distances, and wavelengths. This sequence traces how its coma and tails evolved as it approached the sun, reached peak heating, and then began drifting back into the outer regions of the solar system. Now that 3I Atlas is moving farther away and gradually dimming, this suite of observations becomes the permanent, definitive record of its passage. It gives astronomers the raw material they need to reconstruct the comet's structure, behavior, and history, not just during this flyby, but across the billions of years it spent wandering the galaxy. One of the most important aspects of 3I Atlas is that it doesn't behave bizarrely. In fact, it behaves strikingly like many solar system-born comets. That consistency is exactly what excites scientists, because it allows direct comparisons between icy bodies that formed around our sun and icy bodies that formed light years away. Early spectroscopic data hinted at a higher than typical carbon dioxide to water ratio, unusual for many of our comets, but still within natural variation. The ultraviolet readings NASA just released will help determine whether that ratio reflects its primordial composition or the effects of billions of years of cosmic radiation exposure. Radiation, after all, is a powerful sculptor. A comet drifting through the Milky Way for millions or billions of years is constantly bombarded by high-energy particles that darken its surface, alter molecules, and sometimes chemically remodel entire layers. Understanding how these effects show up on 3I Atlas could reveal not only what the comet is made of, but how long it has been drifting through interstellar space, and what kinds of environments it has passed through. Another major point of interest is the structure of its coma and tails. Multiple images show asymmetric dust patterns shaped by its unusually high speed and the angle of solar radiation. Because interstellar comets tend to move much faster than comets native to our solar system, the dust and gases they release behave differently. Jets erupting from the nucleus stretch, twist, or curve in ways rarely seen in slower-moving comets. Comparing these patterns with what we saw from 2I Borisov may help scientists identify visual signatures that reveal whether a comet originated outside the solar system, even before spectroscopic data confirms it. NASA also used the newly released data to directly dismiss the wave of online theories claiming the object might be artificial. The theories gained traction because early low-resolution images showed odd brightness levels and irregular shapes, perfectly normal artifacts caused by angles, resolution limits, and image processing. The new high-resolution frames show exactly what scientists expected. A classic comet profile with a dusty, expanding coma, a bright core region masking the icy nucleus, and dynamically shifting tails shaped by sunlight. One of the most fascinating questions now concerns the comet's age. Its velocity is extremely high, higher than the speeds of nearby stars orbiting the galactic center. This suggests that 3I Atlas may be ancient, potentially billions of years old, and likely formed in a star system older than our own. If true, this comet isn't just from another solar system. It's from another era of the Milky Way. That makes it a time capsule. As it warms and releases trapped gases, it reveals clues about conditions in long-gone planetary systems. Did ancient comets contain more carbon dioxide? Were their organic compounds different? Were they shaped by different radiation environments? These are questions we cannot answer by studying our own comets alone. Interstellar visitors like this one are the only physical samples we'll ever get from worlds orbiting distant stars. The new images and measurements now give astronomers the most detailed data set for any interstellar comet since Borisov. Researchers can finally test long-standing theories about radiation processing, dust dynamics, and the chemistry of icy bodies formed in alien systems. With the comet fading, the scientific focus shifts from observation to deep analysis. Because the data spans multiple wavelengths, scientists can track which ices evaporate at which distances, which molecules dominate its coma, and how dust grains distribute around the nucleus. If the comet truly formed in the early days of a long-dead star system, these details may reveal what kind of star it orbited and what kind of environment shaped it. NASA also emphasized that the comet was never a threat to Earth. At over 170 million miles during closest approach, it was far beyond any plausible risk. But the public reaction underscored an important lesson. When rare cosmic events occur, even brief communication gaps are enough to spark widespread confusion. Future interstellar discoveries will likely be handled with more frequent updates to avoid misinformation. Tracking of 3I Atlas will continue as long as it remains bright enough to detect, though it will fade quickly as it heads back into deep space. But the scientific value of the data collected so far will last for years. The event has also reignited interest in missions designed to intercept interstellar objects. Previous visitors like Oumuamua and Borisov moved too quickly for any spacecraft to reach them, but new proposals call for rapid launch interceptors ready to launch the moment the next object is detected. Ultimately, 3I Atlas serves as a powerful reminder that our solar system is not isolated. We are part of a vast galactic ecosystem, and from time to time, objects from distant stars drift through, carrying ancient materials and secrets we could never study otherwise. NASA's newly released images capture this brief encounter in stunning detail, giving scientists a priceless look at a traveler from another world, and perhaps another age. As analysis continues, this rare visitor will help reshape our understanding of how planetary systems form, evolve, and scatter their icy remnants across the galaxy.